Welcome back. We're doing question 8. Let's have a look at it. We'll never start here. I'll start here. Okay. Got y-axis and an x-axis, and it's looking for a. So I don't really need to read that. I know how to do this. Minus 1, 1. So this is called your split attention. It's from cognitive load. And what you want to do to keep your cognitive load low is do not split your attention between two things. Look at the drawing and look at the questions, and then we can come back and think, do we need to read something more to understand? But if you think we're getting on fine, what are the coordinates of B? Then you do not need to be reading up there and slowing yourself down. 5, 5. Show that the point C. Okay, so they're saying show that. You see, we can make this out to be 2, 3. So we know it's 2, 3, and so long as we get that, then we're fine. So show that the point C is the midpoint of the line segment. Okay, so let's go to our tables for the formula for the midpoint. So just after geometry, we have coordinate geometry, and our midpoint formula is add up the x's and divide by 2, the average of them, the mean of them, and add up the y's and divide by 2. Okay, so let's be clear here. This is x1 and y1, and this is x2 and y2. Okay, and when we're adding them, we're literally saying what it says here. 5 minus 1 is 4. Let's write down the formula. x1 plus x2 over 2, y1 plus y2 over 2. That's what we're getting. So this tells me add the x's. 5 take 1 is 4. That's adding them. 4 divided by 2. I'm putting everything on, but you don't have to. 5 and 1 is 6. 6 divided by 2. So 2, 3. And show that is the midpoint, and say, I don't know how to show it. Like what you mean? We did show it. So as expected. C equals 2, 3. Now, my compass. There's another thing we can do, and this is geometry, and it's not what they expected. But I'm going to show it to you because geometry and coordinate geometry sits on top of geometry. And what I'm doing now is geometry. Okay, in other words, I could be doing this without any grid, just the points. And that is, I could be doing an arc all the way up and down there with the length of AB, and I could be doing another arc here, and then what I'm doing is I'm making a rhombus. I better do this in pencil, and you could say you don't have to do that right now, not this question, but it is a great chance for us to see how to bisect, how to get the midpoint. I'm just showing you that this is a rhombus because all of those values are the same as my radius. So it is a rhombus. And what are the properties of a rhombus? One of the properties of a rhombus is really important, is that the diagonals bisect each other. Not only bisect each other, but at right angles. We care that they bisect each other, so that's equal to that. Therefore it's midpoint because they're collinear. Okay, they also bisect each other at right angles, which is really cool. Okay, show that from C to B equals the square root of 13. Show that from C to B. Now we can do a helper triangle here. It's the easiest because it's so quick. We have 3 and 2. So you can use coordinate geometry, but you can also use the fact that this is definitely a right angle. So I'm going to use the well, what am I going to do? Okay, so let's take this formula. So we have 2, 3 here. We will write down the formula just because I think you might want me to, but so we'll say it's not PQ we're using, it's not distance PQ, it's distance CB. So distance CB equals the square root of the difference of the x's. Now, by the way, they could be bars, which are modulus or distance. They don't have to be brackets. It would have been way better if they were bars, because it doesn't matter which way you go, you're only looking for distance. Okay, so we're going to put bars there. I'll show you what I mean later. Okay, y2 minus y1 with bars. You have bars on your calculator. You have this thing. It's the modulus, or the size of minus 7 equals 7. Okay, so it doesn't matter if these are negative or positive, so you can always make them positive. Anyway, the point is we have 2, 3, and we have 5, 5. So I'm going to put my points here. 5. Well, I've already done my helper triangle, which is 3 and 2. So what you have here is the square root of 3 squared plus 2 squared. Okay, 9 equals the square root of 9 and 4 equals the square root of 13. That's it. 3 and 2 at right angles turn into 13. You see. Okay. Work out the length of the circumference of the circle in the coordinate diagram. Give your answer correct in one decimal place. Okay, so the circumference of the circle is 2 pi r. We go way back to our lengths and area here. We sketch this. And we write the one we want, with the formula we want, which is L equals 2 pi r. Now we can sub in. Now what is our r? It's root 13. So L equals 2 multiplied by pi multiplied by root 13. We don't want any accidents with, or we don't want our calculator to get upset, so you have to put the multiplication signs there. Correct to one decimal place, that's great. That's telling us it's going to be decimal. So 2 multiplied by pi, or on the other calculator it's behind the 7. No, I put 2 multiplied by pi is in the middle, shift middle, multiplied by root 13. Now if I just hit equals now, it's probably going to actually, okay, there was so much mess there, it went like this. Okay, so equals. Now I'm going to go 22.654 dot dot dot. It'll go do 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 dot dot dot. Now I go and looking what they want one decimal place. I'm going up, approximately equal to 22.7 units. It didn't say, so units is U. Give your answer correct in one decimal place. Another line segment PQ. Now notice they went line segment PQ. You can get that pronunciation from your geometry page. So you can just learn how to speak geometry by speaking from the geometry page. So when you see this, you say line segment from A to B. So another line segment from P to Q. Where's P and Q? We don't know, do we? Yeah, so they're anywhere in there. Where's and if we're asked to find them, we asked to find them. If not, it doesn't matter. Is also diameter of the circle, and passes through the point C. Okay, so it passes through here, and the equation of the line. Well, sure, to give us the equation line, so we can check that it passes through here before we get on to anything else. It says 3x. I'm writing it so that I can kind of sub in because I hate the way they're so small. So let's put in 2, we get 6. Put in 3, we get 6. So yes, definitely it contains 2, 3. And it say it's perpendicular, where we can double check. Actually, so it's nice that I've drawn that in. We can double check, so I'll do it 2 ways. One way is I want to get y to be the traditional, maybe textbook way. We're going to exploit this y equals mx plus c. So we know if we get it in, if we isolate y, the number in front of x is the slope. So let's transpose the 3x term, minus 3x plus 12 stays where it is, and divide down the 2. Okay, so it tells us the intercept is 6. We can see that there anyway, and it tells us the slope is negative 3 over 2. We can probably see that 1, 2, 3, and 2. There's your helper triangle, 3 and 2. So yeah, it's fine. Okay, show that AB is perpendicular to PQ. So the slope of PQ equals negative 3 over 2. The slope of AB, we can use our helper triangle here. It's positive 2/3 or bigger, but we can use the 2/3 bit, or 4 over 6, but we can use the 2 over 3. So the slope of AB is 2 over 3 positive. Okay, to show they're perpendicular, you multiply them together. So you say, hey, guess what I'm going to do now? I'm going to multiply slope of PQ with the slope of AB. I'm going to multiply them out, minus 3 over 2 times 2 over 3. I'm going to get equals minus 6 over 6 equals minus 1. And here's what you do now. It's really important. You use this logical language. Sets and logic. So where the sets are, so we have logic. And so we go to page 23. Actually, the following, that will be sets. But just after sets, page 24, you have this one here. Now you don't have to know them, but you'll see them in marking schemes. They're really cool, and especially when we get on to theorems, these are very important. So these two are very important. This one is if a converse exists, and this one if it doesn't. So implies. So the first thing implies the second. This one, the first thing implies the second, and the second thing implies the first, like Pythagoras' theorem. Okay, so we're using this one, which implies. So once you get your minus 1, you say, which implies that PQ, the PQ line segment is perpendicular to AB. You can just say PQ is perpendicular to AB, and I'll show you why. Because the line PQ goes on forever, but that doesn't matter to change the slope. So you can say PQ is perpendicular to the line AB. And just to bring you back to your coordinate geometry space, you'll see that definition there too. Here it is. AB, line through AB. So, which implies that the line through P and Q is perpendicular to the line through AB. Lovely. That minus 1 implies that. Construct the line segment P to Q in the coordinate diagram. Well, I've actually done that already. Okay. The only thing is, how are we supposed to know where P and Q stop? To see, I mean, I can pick any. What I'm looking for maybe is a lattice point, like that and that. Just want to see. Yeah. Okay. Let me check. Is 4 0 on this line? 3 times the x value, 12 plus nothing is 12. Yeah. And is 6, is not 6 on it? Yeah. So that's what they want. You see, I've kind of already done it by being creative and showing you stuff. I've already done the work because it just seemed natural. So I'm going to call P out 4 up 0. And I'm going to call Q, and I presume they'll tell me they're interchangeable, it doesn't matter which is which, 0, 6. It's kind of open-ended because there would be other points as well. But that's what I'm going to rest it on there. It's kind of tricky. I had to do a bit of thinking there myself. And we're going to the marking scheme now. We're seeing how we get on with question 8. Okay, so here we go. We got 5 marks. Oh, 5 out of 5. 5 out of 5. Distance formula, root 13. Helper triangle used and everything. Don't have to use only the distance formula. Talk about rise over run. We did it. It doesn't matter. There's all sorts of alternatives and variations. There's the phrase they use. 5 out of 5. 22.6. No, make another mistake here. They should have said 22.7. We got it right, they got it wrong. My God, they have 2 mistakes. That's the difference between the pre and the leaving cert. You get these mistakes that slip through. And imagine not a single teacher fixed it with them the last few months when they were given these. Anyway, so 22.7, and I'll be docking you if you got 22.6. Because I have to apply the rules of maths. Come on, that's a mistake. Accept correct answers without units. Yeah, I put in the U because it should have been there, and you should put it in. They spelled it out. I put a U. I might write the word units in future, so that's a little bit of learning for me. Okay, show they're perpendicular. By the way, how much is that worth? Another 5. Minus 1, which implies, and there you have it there, you see, which implies that AB is perpendicular to BQ. Yes, you can write it out, but that symbol there is universally accepted to be that. And it looks like we're moving in there to the 0, 6 and 4, 0. They're interchangeable. 10 out of 10. 10 out of 10 for the minus 1 bit. 10, 20, and I'll just make sure that the whole thing comes to whatever 8 came to. I'm doing an awful lot of flicking here, aren't I? Okay, but at least it's transparent. You can see the marking scheme. You can see what you got out of 30 for this. We got 30 out of 30 in a funny way they didn't, which is funny. Okay, and that's it for that one. As always, I'll see you in the next one. 16 minutes 23. Oh, and I'm supposed to only spend 10 minutes on it. Lads, you know when I'm teaching you, I'm spending way more time.